Hello Junior 6, welcome to the first lesson in the second term, Unit 1, Lesson 1, the set of integers. Let's see what is the meaning of integers. In our daily life, we count many things using what we call the counting numbers. So if I want to count these objects, I will start with 1 and keep counting 2, 3, 4 and so on. And this set we called it the counting numbers, and we denote it by capital C. What about the 0? If I add the 0 to this set, so I will have a new set called the natural numbers, and we denote to this set by capital N, and n equal the set of 0, 1, 2, 3 and so on. So the counting numbers or the set of counting numbers, if I add the 0 to this set, I will have a new set called natural numbers. So back to the 0, we know that the 0 means nothing, and imagining any number less than 0 is very difficult. But there are many situations in our life we need to use numbers less than 0, or we can call them negative numbers. For example, let's see some examples on the negative numbers and how can we use them in our daily life. In few cold countries around the world, the temperature goes below 0 degree, and we can say in some countries that the temperature is for example negative 10 Celsius, negative 10 degree Celsius. And what if we want to use the sea level to measure the length of these islands? So the first one is, as we see, 10 meters above the sea level, and the second one is 5 meters above the sea level, and this one is exactly the same of the sea level. Exactly the same of the sea level. So its length is 0 meter above the sea level. And what about the last one? The last one here is below the sea level. So we can use negative numbers, and we can say that it is negative 5 meter compared with the sea level. So here we can use negative number and say that its length is negative 5 meter compared to the sea level. Also, we used to see the number line always starting at 0 and just go to the right side. But in fact, the number line also goes to the left side. And what are the numbers that are at this part of the number line? Yes, these are the negative numbers. The negative numbers are just a mirror image of the numbers of the right side of the number line. That we call these numbers the positive numbers. So the numbers on the right side are called the positive numbers. The numbers on the left side are called the negative numbers. And negative numbers are just a mirror for the positive number, a mirror image for the positive numbers. So we say that the negative numbers look just like the positive numbers, and the only difference that they have a negative sign in front of them. The negative sign looks just like the minus sign. So, in fact, if we want to add a positive sign to the positive numbers, we will write a positive sign or a plus in front of all the positive numbers, but to save time, we just assume that the positive numbers doesn't have any sign. So it is not necessary to add a positive sign, which is looks like a plus in front of the positive numbers. So when we combine all negative numbers with the positive numbers and the number 0 in one set, this set of numbers gets special name in math, and we called it set of integers, and we denote to this set by capital Z. So Z is equal the set of positive numbers and the set of negative numbers and the 0. Again, this set is formed from positive integers denoted by Z positive and equal to the Z positive equal to the set of 1, 2, 3, 4, and the set of negative integers and denoted by Z negative, and this set equal negative 1, negative 2, negative 3, and so on, and the 0, which is neither positive nor negative. So the 0 has no sign, positive or negative. So the 0 is a number that neither positive neither negative. And it is so important that you must know that all the integers must be whole numbers. It means that has no fraction or decimal. So 1.5 or 1.5 are not considered as integers. The integer must be a whole number. So if I want to form a Venn diagram for the set of the integers, so we will say that the big set is a set of integers, which is Z, and I will divide it into 3 sets. In the middle part, I will put the set of 0, and to the right, as we said before, I will put the set of positive integers, Z positive, and to the left I will put the set of negative integers, Z negative. And as you know that the 0 with the positive integers form the set of natural numbers, n, and here I will write n, and from this diagram we will conclude some notes. The first one, Z positive, remember this sign, is subset from Z or integers. So sure, of course, that Z positive subset from Z, the set of positive numbers, is subset from the set of integers, and also the set of negative numbers or Z negative is subset from the set of integers or Z. And again, the set of 0 subset from the set of integers. So I have here 3 subsets from the set of integers: z positive, z negative, and the set of 0. Okay. Also, n is subset from z. Yes, n natural numbers are subset from the integers. And z equal the union of n and z negative. Z, which is the set of integers, equal the union between n natural numbers and z negative, the set of negative numbers. Is there any intersection between the positive numbers and the negative numbers? No, of course not. So the intersection between z positive and z negative is phi. Z negative difference n equal z negative. So if I subtract the n or the natural numbers from the set of integers, I will have z negative as a remainder. So z difference n equal z negative. N difference z. N is subset from z, so I cannot subtract z from n. Z is bigger than n, so this cannot be. So n difference z equal phi. Here the set of non-negative integers. Non-negative means all the positive numbers or all the positive integers. But what about the 0? 0 is non-negative, so the set of non-negative integers are 0 and the set of positive integers here equal 0, 1, 2, 3, 4, and so on. What about the set of non-positive integers? The set of non-positive means the set of negative. And don't forget the 0, because the 0 is non-positive. So equal 0 and the set of negative integers: 0, negative 1, negative 2, negative 3, and so on. Here, opposite or inverse. As we said that on the number line, the negative numbers are just a mirror image to the positive numbers. We call them opposite numbers. So every number in one side has an opposite to it in the other side with different sign. So here the opposite of number 2 is negative 2, and the opposite of number negative 4 is 4. Two integers are opposite if they are each the same distance away from 0, but on opposite side of the number line. One will have a positive sign and the other with a negative sign. So we call them opposite numbers, every number in a different side with different sign. Examples: the opposite of 12 is, I will put opposite sign, negative 12. The opposite of negative 10, I will change the sign, equal positive 10 or just 10. And what about the opposite of 0? 0, neither negative or positive, so the opposite of 0 is just 0. Here, the last concept I'm going to talk about today, the concept of the absolute value. Absolute value. What looks like? What is the absolute value looks like? It looks like two straight lines, and there is always a number inside them. Two straight lines, and inside them there is a number, positive or negative. The way that, for example, we can read this is the absolute value of, like this, 4. The absolute value of 4. Or more details, what is the distance that the number 4 is far from 0. The meaning of the absolute value is how far away the number 4 from 0. So the distance between 0 and 4 means the absolute value of 4. Now, on the number line, we find that 4 is far from 0 by 4 units. Here I can count that 1, 2, 3, 4 units far from 0. So the absolute value of 4 equal 4. But if I want to find the absolute value of a negative number, like the absolute value of negative 4, think about it. When you look at the ruler or any measuring tool, do you ever see any negative numbers? Of course not. So the absolute value, since it is distance, has to be a positive number. So on the number line, let's find the absolute value of negative 4. Let's count 1, 2, 3, 4 units. So the absolute value of negative 4 is also equal 4. Okay, the absolute value of a number is its distance from 0 on the number line. Since the distance always has a positive value, then the absolute value of any number is always positive, except for the 0. The absolute value of 0 equal 0. Let's solve some exercises from your booklet. The first exercise, put the suitable sign belong, not belong, subset or not subset. I hope you remember these signs. Belong, not belong, when the relation between element and the set. Subset, not subset, when the relation between two sets. Here, number 1, number A, the absolute value of 8 and Z. First, I have to find what is the absolute value of 8, which is 8. Yes, we said the absolute value is the positive of the number inside the two lines. Absolute value of 8 is 8. What is the relation between 8 and the set of integers Z? Element and set, so it is belong to Z. Number B, 9 over 3 and Z. 9 over 3 is a fraction, but 9 over 3 equal 3. So I got a whole number. So here, what is the relation between 3 and Z? Yes, 3 is belong to the positive numbers, so it is belong to the Z. So the answer is belong. again 15 over 3. Here 15 and 3 over 3 equal 5. If it is a fraction or decimal, so it will be not belong, but here 5 is belong to Z because 5 is a whole number. Number D, the absolute value of negative 35. First you have to find the absolute value of negative 35, which is 35, and n. Is 35 has a relation with n? Yes, n is 0 and all the set of positive numbers. So 35 belong to n. Here number E, the absolute value of 8 plus 4 over 2 and Z. First, find the answer of this operation. Absolute value of 8 is 8 plus 4 over 2. 8 plus 4 is 12 over 2 is 6. 6 and Z. The relation between 6 and Z is belong to. Yes, 6 belong to the set of integers. Number F, absolute value of 3 plus absolute value of negative 5 and Z. Here absolute value of 3 is 3 plus absolute value of negative 5 is 5. 3 plus 5 equal 8. 8 belong to Z. Number G, absolute value of negative 10 plus 2. Absolute value of negative 10 is 10 plus 2 equal 12. 12 belong to Z. And number H, 1 over 3 minus negative 1 over 3. Here absolute value, of 1 over 3 minus absolute value of negative 1 over 3. Absolute value of 1 over 3 is 1 over 3 minus the absolute value of negative 1 over 3 equal 1 over 3. So 1 over 3 minus 1 over 3 equal 0. Number minus itself equal 0. And 0 is belong to Z. Number I, negative 7 and n. Negative 7 is a negative number, belong to the set of negative integers. It doesn't belong to n because n is 0 and the positive integers. Here number J, Z negative and Z positive. We said that there is no relation between Z negative and Z positive, so two sets, and it is not subset from Z positive. What about number K, Z positive and n? I know that n is 0 and the set of positive integers, so Z positive subset from n. Here absolute value of negative 20 and Z negative. First you have to find the absolute value of negative 20, which is 20, and Z negative. Of course 20 doesn't belong to the set of negative integers or Z negative. Number M, n and Z negative. N, Z negative has no relation, so n is not subset from Z negative. 11 minus 5 over 3 in an absolute value. So here the absolute value of 11 minus 5 is 6. 6 over 3 equal the absolute value of 2, which is 2. And 2, what is its relation with Z? Yes, it is belong to Z. The next question, choose the correct answer. Z positive intersection Z negative. We said that there is no intersection between Z positive and Z negative. So I will choose phi. Z difference Z negative. We said that Z subtracted from it Z negative, and I will have N. Z minus Z negative, I will have N. Number C, Z minus N. We just say this, Z minus N equal, yes, Z negative. Number D, Z positive union 0. We said it many times. Z positive and 0, the set of positive integers, and 0 is N. Number E, Z positive union 0 union Z negative. Z positive union 0 union Z negative is the set of integers Z. Number F, N union Z. I know that N subset from Z. N subset from Z. So N is inside Z. So the union between them is Z. Number G, want the intersection between them. The union is the big set and the intersection is the small set. So Z intersection N, N is inside Z, so the intersection between them is the small set or the subset. Here the set of N. The union is the big set, the intersection is the small set. So Z intersection N equal N. Number H, N union Z negative. N union Z negative. So N and Z negative together will form the set of integers. Number I, the complement of Z negative with respect to Z. What will complement Z negative to reach to Z? What I need to add to the set of Z negative to reach to Z? I will add, yes, Z positive or 0 or Z positive union 0. To reach to Z positive, from Z negative to reach to Z positive, to complete the set of integers, I will need to add Z positive union 0. Number J, the complement of Z positive with respect to N. What Z positive need to complete and to reach to the set of N? Yes, it needs 0. It needs 0. Write an integer to represent each situation. Number A, a temperature is 14 Celsius below 0. So when the temperature below 0, it is negative 14. A profit, yes, when you gain money, so it is 50 pounds. So profit here means you gain money, so it is positive 50. When you lose money, so you can represent it with negative number, so it is negative 30. 10 steps forward. When you move forward, you can move with positive, so it is 10, positive 10. But if you move backward, you will move negative 10. A decrease of 30 pounds, so it is negative 30. A weight loss of 20 kilogram. You lost here, so it is negative 20. Okay, next question. Find the result of each of the following. Absolute value 5 plus absolute value of 2. So absolute value, of negative 5 plus absolute value of 2. Absolute value of negative 5 is 5 plus absolute value of 2 is 2. So 5 plus 2 equal 7. Number B, absolute value of negative 50 plus absolute value of 30. Absolute value of negative 50 is 50 plus 30 equal 50 plus 30 equal 80. Absolute value of 0 plus absolute value of 5. Absolute value of 0 is 0. Absolute value of 5 is 5. So 0 plus 5 equal 5. Number D, absolute value of 0 plus absolute value of negative 7. Absolute value, as we said, of 0 is 0. Absolute value of negative 7 is 7. So 0 plus 7 equal 7. Absolute value of negative 4 plus absolute value of negative 3. Negative 4, its absolute value is 4 plus absolute value of negative 3 is 3. So 4 plus 3 equal 7. Absolute value of negative 5 times absolute value of negative 7. Absolute value of negative 5 is 5 times absolute value of negative 7 is 7. So 5 times 7 equals 35. 9 times the absolute value of negative 3. Here 9 times the absolute value of negative 3 is 3. So 9 times 3 equal 27. Okay, number 5. Let's represent the following on the number line. Number A, 3, negative 4, 1, and negative 2. So if I want to represent these numbers, I will have to first draw the number line, the 0 in the middle, the positive numbers to the right, and the negative numbers to the left. Where is 3? I will just put a dot on the number 3 and I will shade this dot. Negative 4 and then 1 and negative 2. Easy and simple. So number B, negative 2, negative 1, 0, 1 and 2. Again I will draw the number line and I will put the dots. First negative 2, negative 1, 0, 1 and 2. I can see here that these numbers are after each other, so I can join them with a line. There is no gaps between the numbers like the first one. So in the first one I will just represent the numbers, but here I can just connect them with a line because there is no gaps. Number C, the set of negative 3, negative 4, negative 5, negative 6 and so on. Again I will draw the number line. I will start with negative 3, I will put a dot, and negative 4, negative 5, negative 6 and so on. How can I represent this? I will just draw an arrow starting from negative 3 and go to the left side to the infinity, but in the negative side. Negative 3, negative 4, negative 5, negative 6, negative 7 and so on. And just the arrow will go to the negative side. Number 6, if the absolute value of x equal 5, then x equals space or space. Here x is an absolute value and it has an answer which is 5. So x could be a positive number or a negative number. So x could be positive 5 or negative 5, because both of them has a value of 5. The absolute value of 5 is 5, and also the absolute value of negative 5 is 5. If 4 subset belong to the set of 7, x and negative 3, then x equal, of course, negative 4 belong to this set, so the x will equal negative 4. If negative 4, absolute value of negative 4 equal x, then x equal, so here of course the absolute value of negative 4 equal 4, so x equal 4. Okay, Junior 6, that was the set of integers. Thank you and see you in next lesson.